So let's do two new operations that we need to know primes to be able to do it. What does GCD stand for? Greatest common divisor. What is that? It's the biggest number that divides A and divides B. And so what I'm looking for is, this is the largest int, let's call it G, such that G divides A and G divides B. So obviously it's smaller, it's to the left of or at A and B. I'm looking for the biggest number that divides A and the biggest number that divides B. Obviously A and B are options, right? Because A divides A and B divides B. So those are possibilities. All right, what's the LCM stand for? Least common multiple, which means it's what? I want the smallest int, let's simply call it L, such that A divides L and B divides L. The greatest common divisor is the thing to the left or at A and B that divides them both. It's kind of a smaller number, right? What's the least common multiple? The guy on the other side that A divides and B divides. We're flipping the question of the two. If we're wanting to find that, finding the GCD and the LCM, the first thing we could do is say A is equal to, let's do prime factors. Let's find that unique signature for A. It's some sort of prime, some sort of prime, some sort of prime, and it has so many of them, right? And then B is going to be some prime, up to some prime, and it has so many. So for example, let's say A was equal to 2 to the 0, 3 squared, 5 to the 1, 7 to the third. And then B was equal to 2 to the 1, 3 to the 0, 5 to the 2, and 7 to the 0. Whatever number that is. Let's say I already did the prime factorizations. And I wrote it so that they all have common primes, right? You have a 3 and you have a 3, but one goes, I don't have any 3s. Yeah, you don't. I wrote 0. You have no 3s in your prime factorization, because I'll just write 3 to the 0, which is actually 1. So I write my prime factorization in the way that I write all the common shared primes that they have. If this is true, then the GCD is easy to find. The GCD is you take the primes that you see and you ask for what's the minimal between them. What's the minimal between them? And what's the minimal between these? So for our example is, what is the GCD of A and B for our example here? For 2, what's the smallest number? How many does A have? How many 2's does A have? 0. How many 2's does B have? 1. So what's the minimal? What are the minimal number of 3's? What are the minimal number of 5's? And what's the minimal number of 7's? And so that's just going to be 5. That would be the GCD. 5 is the largest number that divides both of them. The LCM of A and B are still the primes, but now I'm going to take what's the largest power. So for our example, the LCM of A and B, we have 2. What's the largest number of 2's I see? 1. What's the largest number of 3's that I see? 2. What's the largest number of 5's that I see? What's the largest number of 7's that I see? Most of the time when I ask you for, like, the book will give you the multiplication. I don't want that. I want prime factorization left like that. Because it actually proves to me that you knew what you were doing. The rest of it's just arithmetic. Hopefully everybody can multiply that. It would take a long time doing it by hand, but is everybody okay with that? This actually has a nice feature. What would happen for the GCD times the LCM? If I did the GCD times the LCM, the GCD says take the smaller of the two numbers, and the LCM takes the larger of the two numbers, which would mean that you took the two numbers. And if I take the two numbers always, it ends up being that if you take the GCD and the LCM, that's just A times B, which actually gives you the ability to find one if you know the other. If you know the GCD, LCM is easy. Take the GCD across. If you know the LCM, you can find the GCD. Take the LCM across. Next class, we're going to find a fast way of doing the GCD because prime factorization is incredibly computationally costly. And we're going to talk about Euclid's algorithm.